So in this section, we're going to look at equations and graphs of trig functions and do some word problems associated to them. So I want to start by looking at the two different options to solving an equation. So the first option is using setting the equation equal to 0 and using your x-intercepts. I use this method anytime I want to solve an equation. So every equation I want to solve, I set it to 0, put it into my calculator, find the x-intercepts. Option number 2 is y1, y2 intersect. This method, where you put the left side in y1, right side in y2, find where they intersect, the x-coordinate is the solution, is great for word problems, and I also use this method anytime I want to check to see if I've solved something correctly. In these questions that we do, you're either going to be given an interval for domain or not. So if you have a specific domain given, I'm looking for a specific solution. If you don't have a specific domain, I'm looking for a general solution. That's all the solutions from 0 up to the period. And then you just add on multiples of the period to each of the answers. So let's look at an example here where I'm solving for sine 2x equals 3 on the domain 0 to 360. So notice I have a specific domain. Specific domain means a specific solution. So I want to only look at solutions between 0 and 360. So you can see here I've set my window setting to reflect the domain restriction of 0 to 160. Because I'm dealing with restrictions in degrees, my mode is in degrees as well. Now before I can solve this, I need to set this equation equal to 0, and I'll do that by subtracting 3 from both sides. So this is the equation that I'm going to solve, and I'm going to find the x-intercepts for those solutions. So looking at my first solution, I put it into my calculator, and I see that my first x-intercept, 24.3. And I can see there are 1, 2, 3, 4 x-intercepts up to 360, hence why I have 4 solutions. So I just find each solution one at a time, and then I can state all 4 of my solutions rounded to the nearest tenth. So that specific domain has 4 specific solutions. I rounded them all to the nearest tenth. So I want to look at this question here and look at how do we solve this if we're looking at a general solution. So for a general solution, again, the first thing I do, just like I did on the other page, I set it equal to 0. So that's the equation I'm solving. But this time I'm not given a domain restriction. So I need to figure out what my period is. So because I'm dealing with degrees, solution in degrees, I do 360 divided by my b value of 2, gives me a period of 180. So I want to find all the solutions from 0 to 180, and then the cycle will repeat. So I just use those solutions and add on multiples of the period. So again, I am going to use my window setting to do that. So you'll see that my window setting here is set between 0 and 180 because that is 0 up to the period. Okay, so looking at solution number 1, 24.3. I can see there's one more solution by the time I get up to 360. So looking at my second solution, 65.7. So I'm going to take each of those solutions and add on multiples of the period, which is 180. So I do that, and there is my answer, 24.3 plus 180n, and 65.7 plus 180n. Okay, let's look at a word problem. So in this word problem here, we have the height of a ride on a Ferris wheel, where h is the height in meters, t is the time in seconds. So given this equation, what are the max and min heights of the wheels? So maximum is your midline up the amplitude. Minimum is midline down the amplitude. So looking at my A and D values, A and D. So my maximum is going to be 12 plus 10, which is 22 meters. My minimum is going to be 12 minus 10, which is 2 meters. Okay, next question is asking you, how long does the Ferris wheel take to make one revolution? So making one turn, that's period. So period is 2 pi divided by b. For word problems, we always want to deal with radians. So 2 pi divided by my b value of pi over 30 gives me a period of 60 seconds. Okay, next question. How long after the wheel is at its lowest point does it reach its highest point? Let's think about the sine graph. The distance between the lowest and the highest point, that is half of the cycle. So max to min is half of the cycle. So if a full cycle is 60 seconds, I'm going to look at half of that, which will be 30 seconds. Okay, and then the last question says, during the first minute of the ride, at what time or times will the rider be at a height of 20 meters? So 20 meters is a y value. This is an example of y given x needed. So in that case, whenever we do that, we do y1, y2 intersect. So I'm putting my equation into y1, I'm putting that height of 20 into y2, I want to find out where they intersect. So I do that, putting that into my calculator, and you can see I get my first intersection point, 23.9 seconds, and my second point at 36.1. Notice also that I set my window setting to be from 0 to 60 because they said they wanted all the times within the first minute. So 60 seconds equals 1 minute. If you set your window settings to kind of accommodate the restrictions of the question, it saves you having to solve extra parts of the question and throw out inadmissible solutions. Okay, so for this one here, I'm given a scenario, no equation. I'm going to actually build the equation. So we have a Ferris wheel that has a radius of 10. So that's just the distance from the middle to any point. So that's a distance of 10. And this is also a distance of 10. So we saw in the last question, I know that's the amplitude because that's how much it varies from the low to the middle to the high. Now it rotates once every 40 seconds. Okay, that's my period. Now, if I take my period and I divide it by 4, because remember there's a quarters, all of the graphs, sine and cosine, are split into quarters. What that means is that every 10 seconds, something important will happen. Now, passengers get on at the bottom right here. This is where they get on. And this point is 1 meter above the ground. So I want to graph the first 2 turns of the Ferris wheel. So let's figure this out. The minimum height is at 1. And then plus 10, the midline is at 11, plus another 10, the maximum is at 21. So I want to use all of those parts on my graph. So let's look at graphing the minimum and the maximum value first. So minimum at 1, maximum at 21. The midline right in between. Now let's talk about those quarters. I said everything is split into 10 seconds, which means every 10 seconds something important is happening. It's going to be a key point. So I get on here at the bottom. 10 seconds later, I'm at the midline. 10 seconds later, I'm at the max. 10 seconds later, I'm at the midline. 10 seconds later, I'm at the minimum, and then the graph repeats itself. So if I wanted to do the first 2 turns of the Ferris wheel, it would look like that. So you can see I'm connecting all my dots, and then I just repeat that cycle again. So let's use this information to come up with the equation. So to come up with my A value is max minus min divided by 2, and that's tied to my D value, which is max plus min. So let's do those together. So my A value is my maximum minus my minimum divided by 2. So that's 20 over 2, which is 10. Again, as I mentioned before, notice that that is the radius. Your D value is your max plus your min divided by 2. So that's 22 over 2, which is 11. Okay, let's look at my B value. So my B value, I can use my period to help me figure out my B value. So my B value is going to be 2 pi divided by my period, and my period was 40 seconds. So just putting that in lowest terms, I'm going to get pi over 20. Okay, and then the last value that we need to figure out is my c value. So looking at my curve, I'm looking for a sine equation, and sine starts on the midline. So you see the very first time it starts at the midline here, it's midline on an upswing where a is positive, and that happens 10 seconds into the ride. So that tells me that my c value is equal to 10. So putting it all together in the equation, I have y equals 10 sine of b x minus c all plus d. That would be my equation. Okay, so we've looked at where we have an equation answering parts. We've looked at a part where we have scenarios. We come up with the equation. Let's end with an example where I have a table of values. And we're going to determine the sine equation. So this table of values shows the hours of daylight in Ontario throughout the year. So we have day number of the year and number of hours. You'll notice I highlighted two parts here. This I highlighted because it was the maximum hours of daylight on my table, and this I highlighted because it was my minimum number of hours of daylight on my table. So I'm going to use those max and min to find my a and d value. So my a value is going to be max minus min divided by 2, a value of 3.1. My d value is going to be max plus min divided by 2, and that's my d value of 12.18. Okay, next thing I'm going to look at is the period. So the distance between max and min, the time it takes to go from max to min, is half of the graph. So between 172, the day 172, and day 355, that is half of the graph. So my period, if that's half of the graph, will be double that. So you'll see that I doubled the difference between 355 and 172 and got a period of 366 days. So if that's my period, my b value is going to be 2 pi divided by my period. And in lowest terms, that'll be a b value of pi over 183. So I've got my a, d, and b. Now it's just down to c. So c for cosine first. So remember, the cosine starts either at a max or a min, and we want to find the closest max or min to the y-axis. So looking at this one here, I can see that I have a maximum point at 172, and that's less than half of the period, so it looks like it might be good. I want to check what the other point would be, the other maximum point. If I have one that is 172 days into the year, the other maximum is going to be 366 in the other direction. So since 172 is less than half, I know that this is the best starting point. So I'm going to keep my a value positive because I'm starting on a max, and my c value is going to be the x coordinate of that maximum point. So for cosine, the max is at 172 and 15.8. The c value will just be the x coordinate of that, which is 172. Okay, remember you always want the smallest shift, so that looks to be a good equation. Let's look at sine. So I have again highlighted on there the max and the min, and the midline is right in between there. I'm going to call it the midline-ish because you can see the midline is 12.18. That's pretty darn close. So it's right in between the max and the min. So to look at this here, if that is my midline, I am starting midline on a downswing to get to the minimum. If I'm going midline down, I need to make a negative. And you'll notice I did that over here. I made a negative 3.1. To figure out what my c value is, remember sine always starts on a midline, so this is starting midline on a downswing. So when a is negative, c is going to be the average of the x coordinate of the max to the left and the x coordinate of the min to the right. So I add those up, divide by 2, and I get a C value of 263.5. Now, that's a good equation, but I notice that it's more than halfway into the period of 366, so I'm not convinced it's the best equation. So let's talk about good, better, and best. Good is the equation I just came up with. That's a good equation. But a better equation will have a smaller C value. And I'm convinced there is a better C value, a smaller C value. And that C value is going to be found with my best equation by making a positive 3.1. So let's go back to the table of values and talk about this. I had a max that occurred 172 days into the year, and I had a min that occurred 355 days into a year. The midline, of course, is right in between. Since it was midline on a downswing, my A was negative. Now, if I have this minimum 355 days into the year, remember that my period is 366. So every 366 days, I'm also going to get a minimum. So if I have a minimum 355 days into the year, I know that if I go back 366 days, I'm going to have another minimum day, and that would occur at negative 11. Now, I know we can't have a negative day number, but this minimum is closer to the y-axis than this minimum, which means in between this minimum and this maximum will be another midline, but this midline will be on an upswing, making A positive. So since this starting point here is closer to the y-axis than this starting point here, this will be the best C value when A is positive. When A is positive, the C value is the average of the x-coordinate of min to the left and the x-coordinate of max to the right. So you can see I added negative 11 and 172 divided by 2 to get a shift of 80.5, which is the best shift because it's smaller than the 263.5 that I had before. So this will be my best equation. The A, B, and D values are the same, but the best C is a shift of 80.5. Okay, so now that I have my equations, we can now answer some questions. So I want to estimate the number of hours of daylight for July 24th, which is day 205. Day 205. 205 is an x value. So this is an example of x given and y needed. So if x is given and y is needed, we are going to use the trace function. What the trace function says is if you give the calculator an x value, you will get the y value that goes with it. So let's look at the cosine graph. Cosine graph, there's my equation, and I do trace 205, and I get the number of daylight hours is going to be about 14.8. Let's see if it's the same value on my sine graph. So there's my new sine equation with that smaller shift, and you can see it is also 14.8 hours of daylight on day 205. Remember, those graphs are identical because a sine and a cosine graph are the same exact graph with A, B, and D values. They just have different C values, but you can see they are the same. In this question here, I want to know what day or days of the year would you expect 12.5 hours of sunlight? Now, 12.5 hours is a y value. So this, oh, I'm sorry, it's an x value. What days of the year? No, this is y given and x needed, other way around. So this is y given, let me just correct this typo, y given and x needed. There we are. 12.5 is a y value. So in that case, we're going to use y1, y2 intersect. So using y1, y2 intersect, we're going to get our first intersection point at 86.5. Now you can't say it's 86.5 days into the year because days into the year are numbers and they are whole numbers. So I know this is 12.5 hours right here of sunlight. Just below it would be the 86th day, just above it would be the 87th day. So the question is, how do we round this? Well, if this is 12.5, 86 is below that, it hasn't reached it yet. So I have to say it's on the 87th day. Let's look at my next value. So if I look at my next intersection point here, it occurs at 257, again, 0.5. So this right here is where I have 12.5 hours. So I have 257 below, 258 above. So if this is 12.5 hours, at 257, I don't have that much. I actually have a little bit more. This one here, if I go to 258, I'm going to have below 12.5. So I actually want to round to 257, not 258, because I want to make sure I have that 12.5 hours. So that is going to occur on the 87th and the 257th day of the year. Okay, so that was a really long question. Given a table of values, finding the equations. I have an alternate method which I've created a different video for. So if you want to learn how to use your graphing calculator to do these sine equations when I have a table of values, check out my other video on my YouTube channel entitled Sine Regression on the TI Calculator. In that question, I'll do the last question that I just did using sine regression, and I'll also do practice questions 8 and 9 in this lesson using the sine regression. So something that you can look for if you're interested. So to summarize, I want to find the equation of the graph to identify the max and min values and find A and D that way. To find the B value, I'm going to look at the period and solve using the equation 2 pi over B. The reason I use that is because word problems are always graphed in radians. To find the C value, I want you to find the starting point of sine or cosine. And remember, if x is given and y is needed, use trace. But if y is given and x needed, use intersect. So I hope this video helped. I will see you for the next one. But without further ado, here's my joke. Mom and Dad talking. They're a little bit worried about Mike's obsession with the difference between sine and cosine. Dad says, "Don't worry, it's just a phase." Well, a phase shift, that is.